help us today study the segment addition postulate. Here we are with the segment addition postulate. And let's just look at this situation to illustrate the segment addition postulate and how we can use it. Here's Lola, and Lola's going to jump into the pool. I know from experience that Lola, when she jumps into the pool, she can jump about 3 feet. So let's say if Lola starts out at point A and she jumps into the pool at 3 feet. She can get to point B. Now I know that the distance from A all the way across the pool to point C happens to be 15 feet. So I've labeled all of my distances A, B, and C. A to B is the distance that Lola jumps, and she's going to have to swim the rest of the way. Well, if we know that the pool is 15 feet long, then let's see how far Lola has to swim. Well, we can use the segment addition postulate to set this up. Segment AB, or the distance from A to B, plus the distance from B to C, added together equals the distance from A to C. How far does Lola have to swim? I put a question mark, but could you replace that question mark with an X? And we could set up an algebraic equation to show this situation. So let's just plug in the numbers. AB, 3, plus BC, we don't know what BC is, we're going to put X, equals the full distance, 15. There we are, 3 plus X equals 15. We can solve for X. X equals 12. Now, X equals 12. What is that? That's the distance that Lola had to swim, 12 feet. What if Lola ate all her breakfast in the morning, she got a great night's sleep, and she was feeling great, and she jumps a little bit more than 3 feet. Lola's not always going to jump a whole lot farther than 3 feet, so we're going to work in inches. So 3 feet times 12 inches per foot is 36 inches. And I'm going to add the distance that she may jump further. So I have 36 plus n is the distance that Lola jumps, and it's a varying distance. And for the rest of the distance, she will swim. Let's say I knew that Lola swam 137 inches. And I know the length of the pool is 185 inches. I knew that because the pool is 15 feet long. 15 times 12 is 185. So now let's use the segment addition postulate to set that up. The distance from A to B plus the distance from B to C equals the distance from A to C. I'm going to plug in every term to help us set up that equation. 36 plus n plus 137 equals 185. Now I'm going to be careful here, and anything on the same side of the equation, I'm going to combine like terms. So I have like terms 36 and 137. That's going to be 173 plus n equals 185. We subtract 173 from both sides, and the additional distance that Lola jumped was 12 inches. So in total, if we plug that in, n equals 12, then we know that on that given day, Lola ate all of her vitamins, she got a great night's sleep, she jumped 48 inches, which is 4 feet. Lola jumped 4 feet on a great day. Let's try this example. So here we have a segment with a y, a point on that segment, which creates 3 segments. And according to the segment addition postulate, we have the distance, or the segment xy, plus yz equals xz, the total distance. So once I have that segment addition postulate written out, I'm just going to substitute the expressions that represent each of those segments. So I've got xy is 6p minus 4 plus yz is p minus 3. All of that equals xz, which is represented by the expression 6p plus 1. Now, I've got an algebraic equation. I want to be a little bit careful solving it because it has variables on both sides. But I want to get all those p's together and solve for p. So, I have 6p plus p on the same side of the equation, so I can just combine like terms when they're all on that side. 6p plus p is 7p, and then I've got a -4 and -3 on the same side. I can combine the -4 and the -3. 7p minus 7 equals, no combining like terms on this side, 6p plus 1 minus 6p on both sides, and that just gives us p minus 7 equals 1. Now finish it off, add that 7 to both sides because we are algebra experts. P equals 8. I'm going to underline that. That is our variable. Now we're going to take that variable. Once we've got the variable, all we have to do is just plug her on in. So let's come on over here. P equals 8. And I'm just going to substitute xy is 6p minus 4. So I'm going to say xy equals 6p. Instead of p, I'm substituting 8 minus 4. And that equals 48 minus 4. That's 44, the distance to xy. Put a box around that because that's a main answer. Okay, here we go. We need yz. Yz, p minus 3. Yz equals 8 minus 3. Yz equals 5. Substituted that p for 8. Yz equals 5. And now we've got the last one, xz. And I'll just come right on down here. xz is 6p plus 1. That's a 6 times 8 plus 1. And that equals 48 plus 1, 49. xz. Now here's a great situation where we're not given a diagram, but we can draw what is going on based on what we read. I will help you set up this problem and then see if you can solve it on your own. So it says point O is on DG and between D and G. So I'm just going to draw that. So here is DG, and point O is on DG and between DG, between, somewhere in between. Doesn't mean it's right in the middle, but it's somewhere in between. And so I'm just going to put it O. D, O, OG, and DG. These are three segments that come out of this diagram. Now, use the given information to write an equation in terms of x. And here's some given information. And we will have to draw the diagram ourselves and just label it. So let's do that. DO is 2x plus 1. DG is 10x plus 2, that entire distance. So I like to come down here to make it a little bit more clear that this entire distance, 10x plus 2, is DG. And then we've got one more, OG equals 41. Now substitute all of those expressions in, you'll get an equation with variables on both sides. You got to be a little bit careful. Solve it, and then watch the quick solve after you do it yourself. Thanks for helping with the segment addition postulate, Lola. And thank you for watching.
Come here, Lola.